Hello, everyone. It is a great pleasure for me to be here today. My name is Joana Vieira Duarte, and despite being an excited geologist, I am also very proud to be carbon project developer at Neustark. Neustark turns the largest waste stream into a permanent sink. 2 to 3 billion tons of demolished concrete is produced worldwide every year. In contrast, concrete production is still growing, and itself is responsible for 8% of total CO2 emissions worldwide. This is mainly due to production of cement, which requires bringing limestone to very high temperatures, above 1,400 degrees, to produce clinker, and out of this reaction also releasing significant quantities of CO2. This reaction is called calcination. However, the still piece of hope here is that demolished concrete also contains fractions of cement in it which can react when exposed to CO2. So we can actually reverse the reaction in another one called carbonation. And this is the core specialty of Neustark. And here I will show you how we do it. We partner up with concrete recycling facilities which already recover, crush, and repurpose these materials for the construction of roads, new buildings, or ultimately to landfill. At the same time, we also partner up with biogas plants which, due to the production of our biomass treatment processes, they produce a mixture of CO2 and methane. And while upgrading systems are already available which allow to repurpose the methane into the gas grid for heating systems, for example, the CO2 is often released into the atmosphere. So Neustark enters here. We take the CO2, we liquefy, and transport to concrete recycling facilities. There, the CO2 will enter in contact with mineral waste, with recycled concrete, and the cement fractions will then react with CO2 in an enhanced way to form calcium carbonate. The carbonated materials can be used for exact same purposes as before by our concrete recycling partners, and except if it's exposed to very high temperatures or strong acids, the CO2 is locked permanently. With this process, we managed to reproduce in 2 hours what would take several decades to 100 years to achieve. And we cannot really tell by naked eye. However, if we look into the microscope, we can actually perceive different morphological aspects at the surface of this material. So here on the right, you can see some rhomboedral shapes forming, which are very characteristic of calcite. In this process, we are able to store around 10 kilograms of CO2 per ton of material. Here is an example of one of our sites in one of the concrete recycling facilities. In the back, you can see a big pile of concrete aggregate, and in the front, the key components of our technology. So we have the CO2 tank, where the tank that is delivering the CO2 will be transferred into. We have the vaporizer and process control unit, which will transform the liquid CO2 into the gaseous phase and control the reaction, and the reaction chamber where magic will happen. Currently, we have 19 capture and storage sites in operation, mainly located in Central Europe, and 40 more are currently under engineering and construction. The different sites have an estimated capacity varying between 300 to 3,000 tons per year. What Neustark does, or the key role here, is that we glue all the CO2 value chain together. So from liquefying CO2, constructing the plants and engineering them, planning all the logistics that is required for the transport of CO2 and supply, to the sales of our plants, engineering, maintenance, real-time monitoring, and also for the sales and certification of the carbon credits that are generated. We have already issued verified credits by Gold Standard. We are also partnering up with other standards. The relevant point here that I would like to emphasize is that we are really measuring all data in a real-time basis, which allows to unlock automated reporting solutions with relevant standards. This is how the monitoring looks like. So we consider within our boundaries all the processes that didn't exist before in our partners' process value chain. And this includes the gray emissions for the production of electricity or fuel consumption for the operation of the liquefaction, transport, and carbonation plants. And at the same time, we measure precisely with flow meters the CO2 that is injected and that gets out of the reaction chamber. So at the end, the way we calculate our carbon credits is simply by subtracting to the CO2 that is injected the overall losses that happen in the reaction chamber, the overall gray emissions, and also the embodied emissions linked to the emissions required to build the new infrastructure. Our process can achieve a carbon removal efficiency of about 93%. And this depends, of course, of transportation distances, which might be higher in certain project circumstances, or also on the carbon intensity of the grid mix of that country. However, it is our goal to remove 1 million tons of CO2 by 2030. And in order to do that, we need to diversify our approach. And on one side, it includes diversifying storage solutions by addressing alternative mineral feedstocks, as it's exemplified here. So Neustark already today has contracts with some partners for the deployment of our technology to the carbonation of municipal incineration bottom ash and also construction wastewater. And the last one results mainly of the washing of concrete mixing trucks at their return to the concrete recycling or concrete facilities. As you can see, the potential of these materials is not huge, but if scaled, can be highly relevant. And another advantage of this is that these recovering facilities usually exist or are located at the outskirts of big urban areas. So it makes the supply and transport quite easy. On another branch, we are also trying to expand our offerings by addressing, for example, CO2 as a storage service. We have so far we want to leverage all the experience we have built so far in the CO2 liquefaction, the transport, supply of CO2, our own technology, and also all the monitoring we have achieved and built. An example is a tendering of the Municipal Waste Management and Recycling Department of the City of Zurich, which we won at the beginning of this year, which predicts that 25,000 tons of biogenic CO2 generated from incineration of sewage sludge produced from wastewater treatment processes can be actually stored half in concrete and halfway geologically. This project is not yet set in stone because it depends on the public voting that will happen next week at the City of Zurich. So fingers crossed. On another example, I want to bring the project together. And the project together is led by Neustark in cooperation with Carbfix. And is the continuation of the successful pilot project Demo Karma that Marco Mazzotti will refer to it tomorrow. It predicts the liquefaction and transport of biogenic CO2 captured in Switzerland in biogenic sources for storage in basaltic reservoirs here in Iceland. And for these trucks living from Switzerland up to the border with Germany and then transferred to trains up to Rotterdam and from there to ship to Reykjavík and from Reykjavík again by truck will have to circulate or continue to circulate in Europe. This project is the result of a tendering by the Climate Send Foundation, which is basically a funding created by a carbon tax imposed to all fossil fuel producers and importers to Switzerland, which at the end aims at financing net negative technologies such as ours. Moreover, this project also supports Switzerland's Net Zero 2050 strategy, which out of the 12 million tons of hard-to-abate emissions that will remain, 7 million tons are predicted to be or require CDR, including also geological storage abroad. So I just want to emphasize that around this scale-up pathway that we are trying to navigate, there are two important things. One is to continue to comply with the highest level of rigor and robustness that is required from the MRV perspective, but at the same time to try to focus on diversifying CDR market solutions or services in order to scale climate impact for a sustainable future for all generations in our planet. Thank you very much.